So I'm going to be talking about the CCSDS standardization of some of the various protocols that make up DTN, and I've got a slide that sort of talks about what I mean by that. I've got a couple of slides here that talk about what CCSDS is, a little bit of timeline stuff that is slightly different from what Scott had, and then I'll launch into talking about sort of what it is that we're doing right now in CCSDS and where we are, and what some of the differences are between the CCSDS suite of protocols and the RFCs. And there what we did was we profiled the RFCs in CCSDS in order to make them slightly more amenable to space communication in ways that don't break sort of the base protocol. So the profiles that we did within CCSDS are completely compliant with the base set of protocols, with the addition of some constraints in, say, LTP to make things a little bit more efficient. And then there's some bits that we added on, sort of wrapped around the base protocols to provide some extra capabilities that were wanted by some of the international partners. I'll talk about that in the context of both LTP and BP, and then talk about sort of where we are in terms of what it is we're planning. And I think I've got like a Gantt chart kind of thing there. Next. So CCSDS is this Consultative Committee for Space Data Systems. They are the international standards body that sets the communication protocols for talking with civilian spacecraft for most of the large space agencies around the world. The rough mapping is you can think of them sort of like the IETF for space communication. There are a number of member agencies from different countries, and sort of the whole body works by consensus, where there are two big meetings a year where everybody gets together and argues over what they think ought to happen. There are a number of working groups, and in fact, probably 8 or 10-ish years ago, CCSDS sort of reorganized around a very IETF-like model. So the slide that I've got coming up is going to look very familiar to people. Next slide. So some of the things that go on there, since CCSDS is this consensus organization, in order to advance standards through the organization, you've got to have commitment from more than one agency that they think that the development is something that is useful to do, and more than that, you've got to have commitment of funds from more than one agency. So you've got to have multiple people signing on to do this work. And this sort of goes to what I was talking about earlier in response to one of the questions is, what is CCSDS, what is their job? And really their job is to try to make space communications more robust, less costly, and to provide the opportunity for interoperability among agencies. So really what they're looking for is standardization in order to enable things like cross support, because as various people have pointed out, when something goes wrong, there's not a lot that you can do about it. But you want everybody on the ground who can possibly talk to a spacecraft that's in trouble to start talking to it and telling it, to go into safe mode or do whatever you think you need it to do in order to recover from the problem. So the job there is enabling this cross support and also trying to develop sort of an economy of scale through industry, right? Because as Scott pointed out, there's not a lot of market for rad hard parts. There's not a lot of market for the various other bits of things that go into, say, space communication. And so CCSDS, by standardizing the protocols, is trying to consolidate that market a little bit and make it a little bit cheaper for the various agencies. Next. This is animated. If you go ahead and build it out until you get to a big gray square or a big gray thing that sort of shows up around everybody. So this is the organization of CCSDS. Yeah, that's it. Organized around these 6 areas. So there's spacecraft onboard communications that is looking at how do you build and manage a spacecraft, right? What are some of the application support services that you need? So they're looking at things like electronic data sheets for how can you take bunches of parts and put them together and integrate them into a spacecraft and know that that spacecraft is actually going to do what you want it to do. There's an area in SpaceLink services. This is sort of the bread and butter of what CCSDS has done for a very long time, looking at RF and modulation. How do you get things up and down a space link? So these are the things where you've got to have commonality if you want to have any hope of being able to cross support different missions. And then these diamonded items below each one of these areas are the working groups that are going on in that area. So there's an RF and modulation group, there's a space link coding and synchronization group, et cetera. The orange thing here in the middle is cross support services. That's looking at notions of how does one agency talk to another agency's ground station and tell that agency, here's where I need you to point, here's the link layer protocols that I need you to use in order to communicate with my spacecraft, either in an emergency or for normal operations, right? You can imagine there are times if you've got an antenna and you don't particularly have a spacecraft around at the moment that you have to talk to, it's really to your advantage to make that asset available to somebody else so that they can use it to dump data to the ground or to command their spacecraft, and in return, hopefully you get somebody else's asset where your spacecraft happens to be. The sort of purpley thing here in Space Internetworking Services is where I live. I'm the area director for Space Internetworking Services, which is doing a bunch of things that are sort of application layer like things like voice and CFDP, but also standardizing delay tolerant networking. And here we've taken the work that was done originally, and standardized originally through the IRTF, and have imported it then into CCSDS. There's also mission operations and information management services. They're looking at mainly how do you do spacecraft monitor and control. I'm trying to convince them that they're actually applications and that they want to be using the network. I haven't been particularly successful at that yet, but I'm still working it. Next slide. So there's a bunch of history that goes behind this. This starts sort of where the impetus for the current work in CCSDS has come from, which was the Space Internetworking Strategy Group that was formed out of the IOAG to look at what should we do, and then what should we do about internetworking in space. That was had representatives from multiple agencies and got together several times and essentially came to the conclusion that internetworking was in fact going to be beneficial to the various space agencies. There were a lot of discussions about should this internetworking be based on IP, should this internetworking be based on DTN, and they finally punted and said, look, there are areas where each one works reasonably well. There are people that really are interested in doing sort of direct raw IP to spacecraft, which you can do for sort of some of the low Earth orbit stuff. So the SISG was willing to admit sort of either one of those as a possible capability for internetworking. And they issued this final report in November that was essentially to advance the recommendation that they transition future space mission operations to this end-to-end internetwork model. And again, to use DTN or IP as appropriate for the environment that you were in. Next slide. So this is the sort of the what is DTN versus what is bundle protocol. A lot of people, when we speak of DTN, there's more to it than just this sort of internetwork layer bundle protocol that's doing sort of some of the jobs of IP and some of the jobs of TCP. There's also some sort of convergence layer living underneath it, and in the space community, that's been the Licklider transmission protocol. LTP, what LTP provides there is really reliability on top of the data link, which is not something that the CCSDS specified data links do particularly well without LTP. There are reliability mechanisms in them, but they don't operate very well. And what LTP really did is it took some of the some of the lessons learned out of CFDP's reliability mechanisms, ripped those out, and put them then down as a convergence layer underneath BP, which then allows CFDP running over BP to really be an application over network rather than sort of a monolithic thing that goes all the way down the stack. Certainly BP that we've been talking about today. Also, there's ongoing work in network management and bundle security protocol and the streamlined bundle security protocol. That CCSDS is definitely interested in standardizing, and then key management, routing, quality of service are things that are a little bit further out as far as standardization within CCSDS goes. Next slide. So here's where we are as of now, and I didn't put in the things that are sort of before 2007 here. As I said, there's a lot of history. I've got a whole timeline that goes back all the way to like 1997, 1998, with sort of all the events leading up to this. But late 2007, probably mid-November, RFC 5050 was the bundle protocol in the IRTF. The SysG report came out soon after that, recommending this transition to an inter-networked architecture. And then the stuff that's down here in colors on the bottom are various specifications within CCSDS. So pretty much as soon as the SysG report came out, CCSDS chartered the working group to standardize BP as an internetworking protocol. And the first thing that we had to do was essentially the requirement search that said, what is this, even though there was an existing RFC, and we pretty much knew that that was certainly a candidate for what we wanted to specify, we had to go through the exercise of, okay, what does this thing need to be able to do? So what are the requirements that it's got to satisfy? And right there, we started picking up some extras. As soon, for instance, the service specification for bundle protocol was originally designed to be idempotent. You send a bundle, it's an atomic unit, and off it goes. And our notion at the time was that if you needed to send, a 100 meg file or a gigabyte file, you'd send it as a bundle, and that would be that. And so you might then send, 3 or 4 things if you were sending small commands to a spacecraft, whereupon people said, hey, wait a minute, if those things come in out of order, what am I going to do with them? And we said, well, that's your problem. You're the application. You should know what to do with them if they come in out of order. And they said, oh, no, that can't happen. So that, right there, we picked up the requirement for essentially building in TCP-like services on top of BP. And I'll talk, when I get to the slide that's talking about what CCSDS did with bundle protocol, that's one of the things that we had to do was build up things that look a lot more like TCP. So bundle protocol can provide you the reliability, but in order and without duplication services, we had to layer on top of that. And then off we went, standardizing both LTP and BP. There was, and as you can see, this took several years to get done, mainly because we were going back and forth about what some of those requirements had to be and how they needed to be implemented, and what sort of the form of the specifications that needed to show up within CCSDS. There was a lot of discussion there, again, about CCSDS has their way of doing specifications. My original thought was, hey, we've got this nice RFC, why don't we put a CCSDS cover on it and say, do this? Again, that wasn't really, that wasn't particularly well received. And it turns out that the way the Internet Trust copyrights RFCs, it's somewhat difficult to just take that text and import it into your own document anyway. What we ended up doing was writing essentially a profile of LTP and BP, again, that maintain compatibility with the base specifications, but that add on these extra features. In the middle of all that, one of the other things that came out of the Space Internetworking Strategy Group was the request for this. They looked at these documents that were coming out, and we talked about BP and LTP and what the specs were and what the architecture was, and they looked at all that and they said, "Oh, my eyes are glazing over." I need something that's really simple that we can show to high-level managers, and they'll get this idea. And that was where we picked up this extra book down here, this SSI architecture book, that is laying out at a relatively high level, sort of what the concepts are behind this, and in particular how you'd apply those to space. It's not that we didn't already have tutorials from, say, 2006 that did this, but they wanted one that was at their particular level of detail, and Scott took the lead on producing that, and we got that out after a couple of rounds of review. And so now, as sort of this red line is sort of where we are at the moment, we've gotten through LTP, which is the last I saw. I've been exchanging emails with the CCSDS document editor for final cleanup. It's gone through the entire process, so it is done as far as we're concerned. And we're almost to that point with Bundle Protocol. One of the things that came out of the reorganization of CCSDS sort of around the IETF model was that we acquired the requirement to do interoperability testing between two independently developed implementations of new protocols. And Scott alluded to that earlier at the last CCSDS meeting at Caltech in March. We completed the interoperability testing for BP between DTN2 and ION, and that was carried out between Marshall Space Flight Center and JAXA. So that's now done. We have to get the test report together, which I have. I have to get that submitted with everything else, which I haven't. But I don't expect there to be any pushback on that. So with that, we're now picking up work in contact graph routing and security within CCSDS. And again, this is work that is designed not to try to parallel what's going on in the IETF, but to leverage it and to make use of it in the CCSDS space environment. So contact graph routing is a little bit odd there in that with the way that contact graph routing works, it's not really a routing protocol, right? It's a set of forwarding rules based on the inputs of having this contact plan. So why do you need to standardize this? And my argument there is you need to standardize this because if you've got multiple agencies that are flying assets that might be doing routing, well, they've got to make those forwarding decisions in a compatible way so that you don't end up with routing loops. So you've got to make the same kinds of decisions with the same kinds of inputs so that we can make sure that things actually do get where they're going to go. And also looking at standardizing a security mechanism, that's going to be a little bit different in that we probably can't take just the streamlined bundle security protocol that will eventually come out of the IETF. Because I suspect the way things are looking, the IETF is going to make a couple of changes to the way the bundle protocol works in order to support security. And we don't have the IETF bundle protocol version in CCSDS. We just barely got RFC 5050 through. So we'll probably take something that is a lot like the streamlined bundle security protocol and import that into CCSDS the way it is. We're going to have an opportunity in 3 to 5 years to revisit this within CCSDS. And I'm hoping that by that time, people will have gotten to the point that we say, look, now we want to roll over to the RFC that the IETF has put out, which will be out by that time. And look, this is a relatively small software change that still has to be tested heavily. But as somebody pointed out earlier, the big problem isn't really the software anyway. It's the sort of the mindset, right? If we get people that understand that they're using end-to-end applications over network, and we say, look, we're going to change the way that network works a little bit. Some of these bits are going to move around, but none of the services really are going to change. I'm hoping that won't be too hard to sell. Within CCSDS, the various agencies, their standards budgets tend to be sort of strapped. We can't do a lot at the same time. So you know, as BP and LTP are winding down, that gives us the opportunity to spin up this extra work. Contact graph routing and security seemed like they were probably the next most important things to get onto quick. And that's really pretty much all we can do at any one time. So we're going to work on those. I'm hoping that those are not going to take as long now that we've gotten through sort of this first round of getting some buy-in for networking. And after that, looking at doing some network management work. And I'll talk about the first hop, last hop, and some of this other streaming neighbor discovery. The relationship here is a lot of the work that, say, Scott's been doing in ION needs to be done up front and deployed and tested and played with so that we know what the final right answer is before we go off and standardize within CCSDS. Otherwise, there's just going to be more churn, which nobody likes. So you know, we've got the opportunity where several of the implementations, not just ION, but several of them are well beyond what's been standardized in terms of their capabilities. People can get those, use those, and we encourage them to use those and provide feedback so that we can find out what works and what doesn't, and get the protocols and the services sort of nailed down and gelled better before we go off into the standards process. Next. Okay, so this talks a little bit about sort of what did we do to LTP in order to make it more amenable to CCSDS. Based on RFC 5326, there's stuff in that I think survived to the end that says essentially if there's a conflict between this document and the RFC for something, the RFC wins. That was my last ditch effort to try to maintain compatibility with the terrestrial set of standards. But there are some things in the RFC that can be a little bit problematic for space implementation. There are some values in the report segments and in report acknowledgments that say use a random number here. Great. The problem is that random number is expressed as an SDNV. So it could be really, really big. You know, if you take the full, I think there's also a limit that says that it's not allowed to be more than 8 bytes. But okay, that could be big. So essentially, we said, look, you know, if you're deploying this for CCSDS, pick a random number, but limit it to something under like 2 to the 14 minus 1, which gives you an SDNV that's 2 bytes long. We took in a bit from RFC 5327, the security protocol for LTP, where we brought in the authentication mechanism, but not the cookie mechanism. And that was really sort of an administrative move so that we didn't have to then have 2 different books, one for LTP and one for LTP security in CCSDS. It was just too much overhead in terms of generating the books and putting them out for agency review and having, you know, a lot of people look at them to try to do that for 2 different books. So we just pulled that one bit of security into the base spec as far as CCSDS is concerned. The big thing that got added was this notion of LTP service data aggregation. And the notion there, and that's really what the bulk of this slide is showing. If you think of, if you know how LTP works, the middle pieces of this, exclusive of the outer 2 big white bars, are sort of what you'd expect from a plain LTP reliable data exchange where you're sending data, you're getting report segments and sending report acknowledgements. The outside part adds this ability for an application to send lots of little reliable bits of data and have those all aggregated together by LTP into one LTP exchange. And the point there is that then you've got only one of these report segment and report acknowledgement exchanges that goes on. And I didn't draw it on here, but the space link is the thing that's right in the middle here between the sending LTP engine and the receiving LTP engine. So what the aggregation gets you is if you're sending lots of small data chunks you can aggregate those into one larger LTP block for reliable transmission and get the one report segment, and report acknowledgement covers that whole set of, that whole suite of reliable chunks sent by the application. And what that does is it cuts down on the acknowledgement traffic that you're seeing across the space link. And then on the far side, you've then got to undo all that so that the receiver gets this one large block that's got lots of little pieces in it, and the SDA LTP client on the receiving side then has to break those out and give those off to the receiving applications. Next, for BP, similar thing based on RFC 5050. We pulled in there a lot of extra bits in terms of compressed bundle header encoding and the IPN naming scheme, the extended class of service block. One of the first comments we got back from JAXA when we presented BP to them was, "That's nice. How many classes of service do you have?" We said, "It's excellent. We have 3." They said, "No, we need like a couple hundred." Because they want to have very fine, the notion was that they wanted to have very fine grained control over priorities. So the extended class of service block was born. So did all that. And again, all of these things, the things that we added on top of sort of the base bundle protocol got interoperability tested together with everything else. So these are things that have been interoperability tested between DTN2 and ION and implemented in DTN2, at least by Marshall. They're not all in the DTN2 implementation that you can just pull from SourceForge, although we're working on that. The aggregate custody signal mechanisms, these were things that were invented or developed in response to the CGBA deployment onto ISS. They had the low rate uplink, and I think that they were dealing with something like 108 bits per second of uplink capacity, not because that's what the uplink supported, but that was what they were allocated. And if you're trying to send reliable data down and getting these custody acknowledgements come back, then all of a sudden those custody acknowledgements start to look pretty big at 108 bits per second. So aggregate custody signaling was developed to solve that problem, and we pulled that in as part of the specification. We defined some convergence layer adapters for how you encapsulate BP into some of the underlying protocols. And then again, this delay tolerant payload conditioning is the TCP-like suite of services for DTN. So that if you really think you have to have that, you can invoke those, and it just requires you to have lots of buffering at the endpoints in order to make sure that you get in-order delivery and all the other TCP-like services. Next. Contact graph routing we talked about, right, and so we talked about this before, right? The notion is you need standardization in order to get a consistent set of routing decisions, basically. Next. I should say that this is one of those cases where there's been quite a bit of work that's gone on in contact graph routing, looking at sort of the routing metrics that you need to use, possible optimizations. All of that, I think, has done a lot to make CGR more robust in terms of its data delivery, and also to cause it to behave more like people, or at least more like I would have expected it to. And so having that happen up front before we tried standardization, I think, is a big win. So next. So the next, sort of looking to the far future, how do you build this contact plan? And this is not in the context of scheduled communication, right? Not in the mobile ad hoc context, but just if you have a number of space agencies with different assets, what goes into developing this contact plan? Because nobody is very keen on having the networking system try to control the spacecraft, right? They look at this and you say, well, we're going to point in different, we're going to need to point in different directions to communicate with different things. So how's that gonna work? And they will look at you and tell you, no, you're not going to do that. In building the contact plans, we're going to have to live within what the spacecraft does, because it's there's somebody who's the mission manager for that spacecraft. They've got an idea of what the power budget is, what the, are you going to cause a vibration by slewing the spacecraft, and that's going to get in the way of its science mission? What other bad things are you going to be able to do? So we've got to be able to live within that box. At the same time, we're trying to provide this shared network service that other people can build on top of, and what we would like to be able to do is to get sort of a consortium of the agencies together and say, okay, you've got these kinds of assets, the sort of the lowest layer of connectivity information is visibility, right? When can asset A see asset B? If you're not actually going to start moving spacecraft around in order to enable connectivity, and start from there and say, look, what are the opportunities that, what are the contacts that we can advertise in one of these contact plans and distribute, and what are the needs, right? If you're deploying a new spacecraft to the surface of Mars and you need to get relay service back through an orbiter, what are your data rate kinds of needs in terms of what the raw bits, how often do you need to communicate, things like that, and get the various agencies talking to each other and agreeing to build these kinds of contact plans, and then distribute them back out and use those as the way that we route. Next. Again, looking at adapting really the streamlined bundle security protocol for use by CCSDS, and there probably what we'll do is we'll take all the bits out of SBSP that we can and adapt them sort of back into an RFC 50/50 like BP implementation. And right now we're working that. There's actually a trade study going on that's trying to figure out if this is in fact the right thing to do. So we're back to looking at some of the requirements, but that's going to be a much shorter study than when we got started. Next. Network management. So there's again, this is one of those extra capabilities that we've got above and beyond standardized things that have been standardized. Is essentially a delay tolerant network management protocol. This, you can think of this like SNMP for DTN. It doesn't do quite that in that it's looking to enable a lot more, you can view it as either a lot more autonomy or a lot less interaction, so that SNMP is very much question response based. DTNMP is based on having a remote agent where you can tell it, do these kinds of things. Like, every 10 minutes, send me this kind of information. If these kinds of things go wrong, send me a report that's got this other stuff in it. So that you don't have, sort of constant back and forth between a network manager on the ground and the spacecraft. And the implementation of that is really looking at pulling data in from a lot of different sources, right? There's a ton of stuff going on, and there's a ton of information that is available. Information coming back from ground stations about the quality of the link, information that we can get out of this DTN network management protocol about various parameters of BP. We're looking at building sort of, in the MIB model. There's sort of a BP standard MIB and an ION MIB. So what's the other stuff that we can get out of ION, right? Things about what does the SDR look like. We'd like to pull all of that in, jam it into a database and then build an API, a GUI to spit it out. We're not trying to be the network manager for everything. We would like to be able to consume any kind of information anybody might decide to give us and display it, and then also to provide our information back out of this database to anybody else who might want it. So, not trying to take over the world, trying to be, a facilitator of information exchange. Next. So, this is some work that's been going on in various places, in the IPAS lab at JSC and the Protocol Test Lab at JPL. And what they did was essentially built up a spacecraft monitor and control system that was completely based on CCSDS protocols, including DTN. So when they stitch this together, it's 7 or 8 hops of data back and forth to sort of flight-like hardware and a couple of pretty non-flight-like sensors, like a little fan, back and forth that they can then turn on over DTN and exercise the complete suite of spacecraft monitor and control that way. Next. More future work. We have this, many spacecraft are built with essentially link layer commanding. When everything else goes wrong, all you have is a link layer frame, and you'd better be able to send some commands in that frame that allow you to perform at least some basic operations. Go into safe mode, reboot, look for Earth, look for the next, point at me and look for another command. Operating in a networked environment, you don't necessarily have that. If you build a spacecraft that does not have a direct-to-Earth capability and it only communicates back through the network and something like this goes wrong, say you lose the network stack, how do you tell it what to do? One of the requirements that got thrown in way back was this notion of, how do you do first hop, last hop, emergency telecommand and telemetry? And our notion there, although we haven't done really much more than just think about how to do it, but the notion there is to build sort of a standard application that would run beside, on top of the DTN stack on a spacecraft that is the first hop, last hop, emergency command and telemetry app, and then standardize how you would talk to that. So the notion is for emergency command, you would send a bundle to that application that said, okay, guess what? You're the penultimate spacecraft. Somebody who's your link layer neighbor is in trouble, and I need you to radiate this kind of frame at them, and maybe that spacecraft has multiple radios or an SDR that it needs to reconfigure in some way, but I need you to start radiating this kind of link layer frame at them, this many times per second, blah, 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 at these times, in order to get their attention and tell them to go into safe mode and reboot or get restarted. Those are sort of further out on the list of priorities at the moment, but shouldn't be a very difficult thing, I think, to specify. And I think that's my last actual slide. Yep. Whoa.
Well, first of all, let me thank you, along with all of your colleagues, for the hard work you've done on the CCSDS. This is not a trivial exercise to help that body come to a conclusion about standards for SpaceCom. Is it your sense that the time schedule that you showed us for the standardization of various parts, the security protocol and network management, are timely with regard to planned missions that ESA is involved in, or are we are we behind the curve in terms of getting these protocols into, let's say, the missions that are planned in the 2018, right, 2020 range?
I'd like to be further than we are. I think that we have enough in terms of implementations that we'll be able to move forward. I think that security is really important and will become more important. Certainly, if ESA deploys a DTN node onto ISS, and certainly even if they don't, once you get multiple agencies that are routing through some node, you want to start making sure that somebody's not accidentally commanding your node from their ground station.
Are they participating in any of the experimental activities? The Metron, I guess, is the best example I remember for the ESA team. Are they continuing to participate on a kind of experimental basis, which means that they have a little bit of skin in the game? Right.
So ESA is, in particular, also DLR has been really active. They spun up a group that was looking at doing video streaming over DTN. And as part of that, they built out their own network, their own test network, and then decided that they really didn't like reconfiguring all the nodes all the time because it was too much of a pain. So they went off and wrote their own configuration device, or configuration tool to make that happen. So yeah, they continue to be interested, and in fact, maybe a little bit more so.
Is that tool something that others can get access to? Did they make that open source?
They did, just recently.
That's cool. That's very cool.
I don't remember the URL off the top of my head.
Okay, anybody else have questions? Yes, sir.
So Keith, how do you see there being an opportunity to have some synergy between the CCSDS and the IETF working group?
So what I would like to have happen is I have admonished the CCSDS working group a couple of times already, is to make sure that we get our requirements in front of the IETF so that as revisions to Bundle Protocol are considered, that those requirements get folded in. My one big ask going in was that the IETF working group consider trying to ensure, to the degree possible, that changes that they make are at least gatewayable back into 50/50, so that we can, since CCSDS may take 4 or 5 years after IETF comes out with a 50/50 revision, we'd like to have some interoperability with ground infrastructure during that time. If I can cause the various CCSDS agencies to provide requirements into the IETF and work with the IETF in revising the BP spec, I think that would be a win from my perspective.
What has worked in the past, and sometimes works in the past, is for the IETF to have a liaison to the CCSDS and vice versa.
Right.
This would be one or more parties that could actually attend both meetings, and bring these requirements back and forth.
Right.
That's the ideal world, of course.
Yeah, I think we're certainly open to that. Marc Blanchet almost can serve, in that capacity a little bit, since he's been involved in the DTN work, but he obviously he hasn't been able to go to both meetings lately because they keep overlapping. CCSDS is working on that. And other than that, Scott and/or I can serve as liaison between the two groups, especially once we cause them to not overlap.
That would be great. Mm-hmm. Thanks.
So this is from the webcast. This is Lee Torgerson from JPL.
Hey, Lee.
It's not a question, it's a comment. Just wanted to point out that IPAS, the Lab for Avionics Power and Software Development, and MCC have been using DTN as the base comm system. DTN is very robust and is operational in this environment, and I think they've been using that, according to him, for 2 years, last couple of years,
right,
24/7.
And okay, so that was going to be my question. I know that they've used it for a couple of years, and that there have been long-running experiments there, but I didn't realize it was 24/7 for the full 2 years. Cool.
Any other questions for Keith? Going once, going Vent has one.
Thank you, Keith.
Oh, thank you.
You don't have a question?